Hi guys, welcome back. It's Professor Hank. And in this video, we're going to go through the different types of math operators, the different types of arithmetic operators that you have in Kotlin. So we'll talk about what the math operators are, and then we will have a demo program using IntelliJ, right? I'll go ahead and write you a program from scratch just to illustrate how these things work, all right? So what you have with Kotlin is you've got your basic math operators that you're used to in Java, C++, C. So you've got, the addition operator, you've got multiplication, you've got subtraction, you've got division, and you've got modulus. Okay, so all of those different operators are available to you in Kotlin. So let's go ahead and take a look at what those look like. Okay, let's see an example program. Okay, so let's go ahead and take a look at an example program illustrating all of the different operators. So you've got the standard C style operators here. So you've got plus for addition, you've got minus for subtraction, you've got asterisk for multiplication, you've got a / for division, and you've got a % for modulus division. Here, right? And what's modulus division? This is how you find the remainder of integer division. Okay, so let's go ahead and see what that is going to look like. We'll go ahead and create a function called main, right? Because we have to have a main function, and we'll write a program that's going to ask the user to enter a couple numbers, and then we'll just do the different operations on those two numbers. Just keep it simple, just so you can see how stuff works. So in order to read from the user, we're going to have to import scanner, the scanner library, so that way we can create scanner objects so we can read stuff from the keyboard. So let's go ahead and do that, and we'll create a scanner, and we'll do system.in. Okay, so now we can use next int, next float, etc. to read values from the user. So let's go ahead and put a little prompt here. We'll do print, enter the first number. Enter the first number. Okay, and from there we will read the number in, and we'll just call this variable x. Okay, and we'll say equals s dot next int. Okay, and then we'll get the next number, enter the second number. Okay, and then we'll grab that number, next int. Okay, and then from there, let's go ahead and do the different operations. Okay, so we'll do some addition. So we'll create a variable, call it sum, I guess, and we'll do x plus y. Okay, and then we'll create a variable, we'll call it difference, I guess, and maybe we'll just call it diff equals x minus y, and then I'll create a variable, call this product. This is going to be x times y, right? I mean, so you're seeing it's what you've seen before in other programming languages. So then we got what's the answer from division called? Is it quotient? I can never remember. So x divided by y. Okay, so we'll get that, and then we'll find the remainder. Okay, so we'll do something like var remainder equals x modulus y. Okay. Okay, so we'll just go ahead and display the results. So we'll do something like print line. The sum is the sum of x and y is sum. Okay, so that'll be the first one. Then we'll do the difference of x and y is diff. Okay, and then we'll do the product of x and y is product. Okay, and then we'll do 1 for quotient. The quotient, if that's the right word for it, I don't know. I'm just guessing on that one because I don't remember. It is quotient. You would think, I mean, I had a math minor. You would think that I would remember that. Okay, so then the remainder of x divided by y is remainder. Okay, so I think that's everything. So we'll just do this program, then we'll do a couple of other things just to show you the differences. Let's go ahead and run this. Just to show you a couple of the differences and some other things you can do, right, with the different operators. We'll talk about integer division and floating point division here in a second, and show you how to use parentheses and all of that good stuff. You've got, what you're used to having, and it's building, and you got all the usual stuff, right? C works like this, Java works like this, C++ works like this. There's nothing really unusual here in terms of the operators that you have, right? So you've got the same order of operations, you've got the same use of parentheses, all that kind of stuff. Okay, so let's go ahead and enter 8, and then we'll enter the second number, 3, and so here are your results. Okay, so let's take a look. So the sum of 8 and 3 is 11. That's true. The difference of 8 and 3 is 5. That's true. The product of 8 and 3 is 24. That's true. The quotient of 8 and 3 is 2. So again, what is that? Right? We did integer division here. In case you're wondering, why don't we see decimal places here? Because we did integer division. An integer divided by an integer is an integer. So 8 divided by 3 is 2 with something left over, right? Because 3 divides 8 twice with 2 left over. So you only see with integer division the 2, right? That how many times the 3 divided the 8. And so then the remainder, I should say remainder, of 8 divided by 3 is 2. And that's the result of that, that modulus, right there. So that's what modulus uses or that's what it's for, is to find what's left over in integer division. Okay, so let's modify our program a little bit, and we'll use floating point numbers in this time around, right? So what we'll do is we will do next double. Okay, and we'll see what happens. Okay, so next double. So what will happen here is that next double is going to read in whatever the user typed in and return that as a floating point number instead of as an integer. And some stuff's going to happen, right? So for one thing, we're going to end up doing floating point division instead of integer division. Okay, so let's do it. So we'll do 1.3, and then we'll do 2.6. Okay, so what do we have? Okay, so we've got the sum of 1.3 and 2.6 is 3.904. Now you might be thinking, well, what the heck? Why does it just say 3.9? And where did that 4 come from? Well, computers store numbers as approximations, and so we didn't do any kind of output formatting or anything like that, and so we didn't cut off the rest of all of this stuff, and so it wasn't exactly perfect. Okay, it's close, but it's not exactly perfect because again, computers they store approximation of floating point numbers. But the difference of 1.3 and 2.6 is negative 1.3, so that was good. The product of 1.3 and 2.6 is 3.38, and a really small value here way at the end. The quotient, so 1.3 and 2.6, 1.3 divided by 2.6 is 0.5. So now you can see we got the decimal places because a floating point number divided by a floating point number is a floating point number. And then the remainder of 1.3 divided by 2.6 is 1.3. So you just see that you got the original, because what does it mean to do, you got this original value here that we were dividing by. What does it mean to have the remainder of floating point division? It's nonsensical. So you just give this original value back here. Okay, so let me show you one more thing. I'm going to show you The difference, highlight the differences between integer division and floating point division. So let's go ahead and create, a variable x. We'll initialize it with 5. Then we'll create a variable y. We'll initialize that with 2, and then we'll create the variable answer, and we'll assign it x divided by y. Okay, and then we'll print out the contents of answer. Okay, now when we do that, you might look at that and go, oh, well, 5 divided by 2 is 2.5. This should be easy. Why is he going through all of this stuff with us? Well, that's not the answer. The answer is 2 because, as I said a couple minutes ago, an integer divided by an integer is an integer. Okay, so this is true in C, this is true in C++, Java, this is true in Kotlin as well. Okay, so if you actually wanted to have the decimal places preserved, well, then you have to divide a floating point number by a floating point number. That's one thing you can do. So let's go ahead and do it. So this is now going to do floating point division because it depends on the operands. Okay, the operator is the operator. Its division is the division. It depends on what you're dividing as to what type of answer you're going to get. So take a look. Now we've got 2.5 because a floating point number divided by a floating point number is a floating point number. Okay, but you also have this idea of promotion, okay, in Kotlin, like in other programming languages. So it's going to want to treat both operands as the same type. Okay, so you see how it says 2.5? So if you divide a floating point number by an integer, you get a floating point number because that integer part is going to be temporarily promoted for purposes of the calculation. It's going to be treated as a floating point number. So that way you do get your floating point number. Okay, so that's another thing you can do. Just make sure at least one of them is a floating point number. Another thing you can do is you can multiply one of the operands by a floating point number. Okay, so this side is going to evaluate first. Okay, so 5 times 1.0 is 5.0. Okay, and then you're going to try to divide by 2. Well, the result of that first operation is 5.0 divided by 2, and so then that 2 will get promoted to the 2.0, and so you'll end up with a floating point number divided by a floating point number, and so then you'll get, as a result, your floating point number. Okay, so that's a little bit, maybe a little bit of a hacky thing that you can do, but you can do it. Okay, and you can construct all types of complex formulas, right? You just have to do it in the same way that you do it in other programming languages. So, for example, what's the formula for a slope of a line, right? So slope of a line is, you find the slope is equal to, right, so which is what, m, which is equal to, the difference in the y's, right, y1 minus y0 divided by the difference in the x's. I think that's right. Okay, so you can do all kinds of complex calculations like that in Kotlin as well, and you just have to make sure that you use parentheses to change those order of operations. So we got to have the difference in y's found first before we divide the difference of x's. So you can do something like val y1 equals 5. Then you can say something like val y0 equals 2, and then val x1 equals 3, and then val x0 equals 1, and then you can do val m equals, just like up there, y1 minus y0, and then we divide by x1 minus x0. Okay, so what are we going to get? Okay, and then we'll go ahead and we'll print it. We'll print m. Okay, what are we going to get? Okay, and some of you might notice that I've made a mistake, but I put it in there on purpose. It's not that. Okay, the clue is that I'm doing integer division. Okay, so remember, integer divided by an integer is an integer. So I'm getting 1 here, but is that the correct answer? Not necessarily, right? Because y1 minus y0, what is that? That comes out to 3, right? And then x1 minus x0 is 2. So the answer should be, the slope should be 1.5, but remember, they're both integers. Okay, so integer divided by an integer is an integer. So one way we can deal with this is just to make, one of these guys floating point numbers, or make them all floating point numbers, or even do that little hack that I showed you a second ago. Okay, so do something like that, and then that's going to force promotion of all the other integers to floating point numbers, and then you're going to see that now we've got the correct answer, which is 1.5. So I mean, you've got the same order of operations that you're used to. You can build complex operations just like you're used to. So okay guys, so that's going to bring this video to a close. Hopefully you found it useful. If you did, please consider giving it a thumbs up. If you thought the video sucked, you got the thumbs down as well. Please consider supporting the channel in various ways. You can join as a member, you can do the super thanks, leave a comment, subscribe, hit the bell so you know when the latest videos have been released. And if you're a student of mine, please feel free to stop on my office hours, email any questions you might have, or hit me up on Zoom. Okay, that's everything I got for you this time. Thanks for watching, and we'll see you next time.